Yeah, I'm getting ready to start this wiring pretty soon. I got everything I need. This little motor controller that I talked about before, the little heat sink that was on here, was floating around in the pack, and I thought it had come off. And I found out after I opened the pack that the heatsink had double-sided tape on it, so you peel off the backing and then you press it onto that little microcontroller unit that it mounts onto. So I guess they did that to save on packaging or something, I don't know. But anyway, I thought it was defective and it isn't, so it's okay. I got the unit apart right now. I got the cables out here. Now both of these are the same. The motors are both the same, except one motor turns this, and the other motor is for the top, and this is for the rotation, and this is the rotation on the unit on the top. But the plugs, I wanted to get a plug to fit in here so I could just snap this cable onto there. So I might right now I can use these these little wire things, but I want to get a plug so I can mount the cable right into there, and that way I could take it off. I don't want to hard wire it, but I can test it. Not now, but later. And I got the 5 volts for this pulse generator slash CNC hand wheel, and I got 12 volts power supply. The 5 volts gonna use this phone charger that puts out 5 volts. I already cut the end of it, and that's gonna go onto here, and then the 12 volts gonna go onto here. But what I'll do that later. But the power supply looks just like any other power supply. I guess they're all pretty much standard. And these little pieces that I had holding the belt, I made new ones. And basically they're identical, except on these I have a raised portion on the outside of here, because what was happening was that the belt was sitting in here in these little grooves, and I wanted to capture the belt on the bottom and the top, so the belt was sitting there like that. And then when I put the piece on the top, what was happening was that when the screw was going in there, this piece was bending down to put the clamping force on there. So it was putting basically a bow on the top piece. So what I did with these other ones is that the piece on the bottom and the top still has those grooves in there, but I put a raised portion on both sides. Now this is exaggerated. So that when the belt was clamped in here, these pieces would hit the same time as the belt was getting wedged in there, so it wasn't bowing, because these were hitting each other, making contact, so it was clamping it, and this piece was not deflecting any, both of these parts. So when I put the bolts in there, it clamped down on the belt and on these pieces, because I didn't want it bowing like that, because it was it's just not right, you know. You just don't do it that way. So this is the way I did it. So I made these parts on the printer. These are the parts for my vise. This piece here. To the top of my vise. So what I did here was I put these little like jigsaw looking things in here so when I put the piece in there it would clamp. Of course, you know, this is plastic and I know it's not going to work, but it'd give me a good visual as to what I was trying to do. And when I peeled away this plastic on the inside, it broke some of these pieces here. But nevertheless, so what I did was I made two of them, and they're both identical except for the hole in the middle. One of these is a clearance hole and the other one is a tapped hole. So what it's going to do is going to fit in there like that. See, this also bowed too, but it's going to fit in there, and these slots line up with these holes. Any two of these holes at any time will line up with this slot. Whether I use this hole and this hole or this hole and that hole, any point I'll get two of the holes. So you clamp your piece in there and you can move it, and the bolt goes down through here and it clamps this together, and then you use these bolts to hold it down onto the plate. And the width of this fits in there to hold it in place, keep it from moving, and then the bolts here will bolt that down. So that should give me a low profile and a secure clamping force. So I thought about that, and this wasn't, you know, this isn't ideal because this got to basically cut into the material, and I really didn't want that. And I wanted to use that dovetail that I bought. So I thought, well, let me reprint this using the dovetail instead of these serrated edges. So I redid the model, and I never really printed it again because I thought, well, I'll go ahead and just make it out of aluminum, you know. I was going to make it out of steel, but I thought, well, let me make it out of aluminum first. So I made these parts. This is going to be the one side, and this is going to be the other side. And it's going to work the same way. So instead of making this one piece, I'm making it two pieces. So I made this piece here. This is the piece that's going to slide in there. I made everything oversized because I'm going to get this welded onto here. It's going to get welded here, here, back here, basically all around the part. Now I got this undersize here, so when he fills it up with weld, it'll be the same size as this, and that'll give me a strong weld joint inside of there, because if I just made this straight across here, it wouldn't fit in this slot. So I made it undersized here so that when it got welded, the weld would come out to this size. And the same thing in the back. This is a 3/16 thick, and this slot back here is 1/4 inch. So when I peel a little bit of this away with an end mill, it'll still be a strong weld joint in there. And then I'm going to, of course, drill the hole in here. But after it's welded, you know, I got to go back and I got to true up these surfaces. And yeah, I left, I think, 50 thousandths on everything. Then I'm going to come back and put that dovetail inside of here. True up this surface and true up this surface. And of course, I got to make that flat because that's going to fit on there. But I thought, well, I'll go ahead and make this out of aluminum first, and because normally the material we work with is aluminum anyway. So if I put a dovetail in there, I figure, well, that'll work. You know, it doesn't really have to be steel. I mean, I can make it steel. That's the nice part about this, is that I can take these jaws and take them out and put different jaws in there. You know, if I wanted serrated jaws, I can make up a set of jaws and use the serrated ones and just put them in there. Or if I wanted just flat, I could put them in there. But that's what's nice about this, is you can take these out and interchange them with other items. And of course I got the little hole in there so that the piece won't walk on me. The dovetail will hold it in place, and then the little dowel will keep it from sliding back and forth, so that locks it in place. And I thought, well, I'll give it a try. I think it'll work. It'd be good enough for what I'm doing. And I can always change it up later. So I got to get ready to, I want to wire this guy up. Get these motors running. Of course, they won't, you know, they won't run. I mean, they'll turn, but they won't be positioning anything, because I'll just be turning them with this hand wheel just to see how they rotate. And then I'll put the unit together. Then I can rotate the top unit, take the plug out, put the other plug in, then rotate it this way to see how that works out. And I think it'll be okay. So I just wanted to show you that. And yeah, the other thing I was working on was this piece here. This is the top of the table. The vise mounts on top of here. So I put these, I made this piece to fit in here. Now before, I needed to drive this table. So I talked about making some drive dogs in here. So I put 3 in here. They're just, I took a 5/16 end mill and just sunk them in here. I may put 3 of them in there. And you know, 120 degrees apart. So then I printed this out. Now this has got the three drivers for the dogs. I printed the belt pattern, and I skipped a couple. I skipped them where the dogs were, and also skipped them over here too. Now the reason I did that is so that the belt would have less drag as it went around, because this is less area for the belt to make contact, so it kind of frees up the belt to rotate a little bit better. So this piece on the bottom, I didn't want this piece to warp. So I made this extended piece so it would have more clamping area on the table. And then I was going to come back and take a knife and a Dremel and just peel that away. And that was going to fit inside of here. But, you know, after I thought about it, I said, well, you know, that would make a nice surface so that this piece of aluminum wouldn't be riding on the other piece of aluminum. Because if you get a little grit in there or something, next thing you know, you start to get some galling, and you just can't get rid of it. You know, a little chip or something gets in there and starts galling it, and you just can't get rid of it. So I thought, well, you know, I'll leave that on there, and that'll act like a little bearing surface, and if any chips or anything get in there, it'll go into this plastic and it won't hurt the aluminum. So I thought I'd try that. If it doesn't work, I can always peel it away. But the when I put these 3 countersinks in here, I did the same thing with the 3D printer, and it's really amazing how accurate this printer is, because all I did was take the little burr off of there, and they line up pretty good. You know, I was really surprised. I thought I'd have to, you know, sand them quite a bit to get this thing to fit. But it's really accurate. I could rotate it and it still fits. I could rotate it again, it still fits. So I was really surprised about that. So we're going to give that a try. So that belt will be in there, and it's going to rotate this guy. Then my vise is going to be on top. Now I had to put quite a bit of angle on here because when it fits in the unit, the top of this plate, you remember this piece here, the top of this plate was just hitting the radius of this, and there's a belt that rides in there that's going to make this thing move. So when this thing starts to rotate, I had to put a little clearance in there so that I could rotate past there without it hitting. Because the rotational point is over here on this surface. The bottom of this surface is the actual rotation point. So when it rotates like that. And this would have cleared, this clears, but when it gets up here, it didn't clear. So I had to take a little angle on there. I think it was like 23 degrees or something like that. So, and I also had to put these little chamfers on the corners here, because when this sits on there, it was pretty much the same thing. That piece was hitting right here, so I had to chamfer that. There was no reason why I had to go all the way up to the top of the table, because that plastic piece only comes about here somewhere. So I had to chamfer these corners, keep that from hitting. Now I could have made this whole unit a little bit smaller, but it'll work. So hopefully the next video I'll have this together, and if I can get these motors wired up right without burning anything up, maybe we can get this thing to rotate. So I just wanted to show you that. Alright. We'll see what happens next time.